Hello, Honors Chemistry, and welcome to Section 2.11. So really, 2.11 just talks about let's do some more problem solving, which really is, and I can't emphasize this enough, right? This is what the vast majority of chemistry is read the problem carefully, right? What are you given? What is your goal? Figure out what conversion factors take you from point A to point B, right? And the thing is that there are some people where you don't even really have to understand what you're doing, but if you just see the patterns and you understand the concept of making units cancel, right? It gets really easy, right? I like to think you understand all of it, right? But there are some people who could probably get by just on pattern recognition. So anyway, let's do a couple last problem solvings from 2.11. So it says that we have a pure gold metal bar displaces this much water. What does that mean? Right, this is the volume, right? That's code for saying the volume of my metal bar is 0.82 liters of water. Well, it is 0.82 liters, right? And we would like to know its mass in kilograms, right? Mass in kilograms is our goal, okay? And obviously in order to get between, I shouldn't have put that there, right? But in order to convert mass and volume of any substance, we're going to need its density, right? That's a necessary thing. So let's go ahead and take a second and rewrite that so we'll know how to use it when the time comes. So this converts between grams and centimeters cubed. This is currently in liters, so I'm going to have to get that in the right unit to use this conversion factor. So let's start with our 0.82 liters, okay? And if we recall, right, we know that 1 centimeter cubed is equal to 1 milliliter, right? That's what I told you to tuck away on the introduction to density, right? So if I go ahead and convert my liters to milliliters, so 1 liter is equal to 10 to the third milliliters, right? Liters cancels. Now I can use this, which says that for every 1 milliliter, I have 1 centimeter cubed, right? Now I can incorporate this, so for every 1 centimeter cubed, I have 19.3 grams of substance. Oh, but we're not done yet because we would like our answer in kilograms. So for every 10 to the third grams, we have 1 kilogram. And then we would be done. Grams cancel, centimeters cubed cancels, mils cancel, and then we just have to make sure we do the math correctly, right? And we should always take a look at the whole thing because it turns out there's a 10 to the third on top, 10 to the third on bottom, and that actually cancels. And we come up with 15.826 kilograms, which will round to 2 sig figs, so 16 kilograms is the mass of my pure gold metal bar in kilograms. Yes? All right. So it says we have a gold-colored pebble is found in a stream. Its mass is this, and its volume is this, and we would like to know its density in grams per cubic centimeter. So we would like to know grams per centimeter cubed. This is our goal. And we would like to know, is it gold, right? So is it gold really is like a secondary question. First, we have to figure out its grams per centimeter cubed, right? So there are multiple ways we can do this, right? So you can take this mass and convert it to grams, take this millimeters cubed and convert that to centimeters and then put mass over volume, or you can put mass over volume first and then do your conversions, whatever makes most sense to you, right? So if I know that density is mass over volume, 23.2 milligrams, over 1.20 millimeters cubed, I could then just go ahead and now this becomes kind of like that speed limit conversion, right? Where we'll just pick where we want to start, right? So I want to take milligrams to grams first. So I know that there are 10 to the third milligrams for every 1 gram, and that cancels, right? And for millimeters to get to centimeters, first let's start in 1 dimension, right? I know that there are 10 millimeters for every 1 centimeter, right? But I'm talking about 3 dimensions, so I'll cube all of that, right? Which then means my millimeters cubed cancels, right? I just have to remember to apply that 3 there. And now I will be in the right unit. And we're going to get 19.33 repeating. Okay, which by the way, so if we pay attention, that's how we get grams per centimeter cubed, right? From the total of our math, right? And 19.33, right? And yes, that is gold, right? Because that goes back up to here. Yes, does that make sense? Alternatively, right, we could have started with our, so we could have done our 23.2 milligrams, right? And convert that 10 to the third milligrams to grams, right? Do that and get our number of grams, right? And then we could take our volume, so 1.20 millimeters cubed, right? And we have 10 millimeters for every 1 centimeter, and cube that, right? And then so that gets 3 places smaller. So 1, 2, 1, 2, 0 centimeters cubed, right? And then I would just take mass over my volume, right? And come up with my density, yes? So I would just do as my last step 0.023 grams over 0.00120 centimeters cubed. And either way, I come up with something that should be about right. Does that make sense? All right, so that's it for chapter 2. Now, the key here is lots and lots of practice, because I said first we got to commit those conversion factors to memory. Then the practice will get easier and easier until all of this becomes second nature. And then this becomes the foundation for everything that we're going to do in every subsequent chapter. All right, so please take this practice seriously. Thank you for listening. Be good, and I'll see you soon for lots of practice. Bye.